Welcome to Networks Professionals.
Hello everyone, and welcome to The Explainer. Today, we're going to be unpacking the unsung hero that quite literally saved the internet from running out of addresses. You know, it's a concept that might sound a little intimidating at first glance, but I promise, once you see it laid out, it just clicks perfectly into place. Okay, let's dive into this. We are demystifying CIDR, and we're going to look exactly at how it rescued the IPv4 internet.
Here's our quick roadmap for today. First, we'll meet CIDR. Then, do a 32-bit breakdown. Move on to doing the actual math, check out some real-world subnets, and finally, wrap up with exactly why CIDR matters so much.
All right, Section 1, Meet CIDR, the IPv4 rescuer.
To really appreciate our hero here, we first need to understand the historical nightmare it was designed to fix. Before CIDR came along, network allocation was, well, it was incredibly rigid. We used this totally restrictive, class-based system, classes A, B, and C. It was basically a forced structure that gave network admins either way too many IP addresses or far, far too few. There was literally no middle ground. But variable length subnetting, that changed everything. It allowed administrators to dynamically slice up the internet in a way that actually made sense for their specific, real-world needs.
Which brings us to our core definition. CIDR stands for Classless Inter-Domain Routing, and as the name suggests, it completely throws out that rigid class-based network allocation. Instead, it uses a super flexible IP addressing method. You basically take an IP address, add a /, and then throw a number on the end, like say /24. So the crucial point is, that number designates exactly how many bits are locked for the network. Think of it like a deadbolt on a front door. Once those bits are locked in place, they belong entirely to the network's identity, no exceptions.
Moving right along to Section 2, the 32-bit breakdown. Let's look at the anatomy of an address.
32. I really want to anchor you on this specific number right now because it is the absolute foundational building block of the entire IPv4 ecosystem. Literally every single IPv4 address you have ever used in your life is made up of exactly 32 total bits.
But you know, those 32 bits aren't just one long continuous string of numbers. That would be a mess. They're sliced up. Specifically, they're divided into 4 equal sections of 8 bits each. And this 4-part structure, this is the exact battleground where CIDR notation does its most important work.
You see, CIDR's entire job is simply to dictate the split between two things. On one side, you have the network ID. Those are the locked bits dedicated to routing. On the other side, you have the host ID, the open, flexible bits left over for your actual individual devices. We're talking your laptop, your phone, your servers. CIDR tells the internet exactly where to draw the line between that locked network and the flexible hosts.
Okay, Section 3, doing the math, the CIDR formula. Don't worry, we're going to keep this super simple.
Before I reveal the secret here, I want you to actually think about it for a second. If you know for a fact you have 32 bits total, and you know CIDR locks a certain number of them for the network, how do we find the number of available IPs left over for our actual devices? Any guesses?
Well, here is the magic formula. 2 to the power of 32 minus n. In this formula, n is simply your CIDR prefix, that is, the number right after the slash. And this brilliantly illustrates how the math works out in practice. You just start with your absolute maximum of 32 bits, you subtract the slash number, which are your locked network bits, whatever number you have left over, that becomes the exponent on the number 2. Do that final little calculation, and boom, you just unlock the total size of your network.
Section 4, real-world subnets. Let's look at some common allocations. Let's take a standard /24 suffix. It uses a subnet mask of 255.255.255.0. Think back to that formula we just looked at. By locking 24 bits, we leave exactly 8 flexible bits. 2 to the power of 8 gives us 256 total IP addresses. This is exactly what you're going to find in standard office, home, or local area networks. It makes it absolutely perfect for your everyday LANs. Just a nice, bite-sized allocation.
But look what happens when we shift that prefix just a tiny bit to a /16. Our total IPs absolutely explode to 65,536. I mean, by only locking 16 bits for the network, we leave 16 bits wide open for hosts. 2 to the power of 16 is over 65,000 addresses.
This massive, massive scale is commonly utilized for large enterprise networks, virtual private clouds, or VPCs, and internet service providers. It is just a shocking leap in size just by changing that one number after the slash.
Now, what's really interesting about this slide is a crucial dynamic you might have already noticed. Your usable IPs are always exactly 2 less than your total IPs. Why is that? Well, because you always lose 2 usable IPs in any block. The very first IP is entirely reserved for the network address itself, and the very last IP is reserved for the broadcast address. So in our standard /24 network of 256, you actually only get 254 usable addresses for your actual devices.
Finally, Section 5. Why CIDR matters. Saving IPv4.
To sum all of this up, the ultimate benefit of CIDR is that it lets administrators allocate exactly the space they need. It provides highly customizable network sizing rather than forcing everyone into those clunky fixed classes. Because of this amazing efficiency, it drastically reduces routing table sizes across the whole internet. But most importantly, it prevents the rapid exhaustion of IPv4 addresses. It literally bought us time. And hey, if you ever need to visualize your own network boundaries or translate some of these complex subnet masks, you don't actually have to do it by hand. You can empower yourself by using tools like the AWS Subnet Management Tool or dedicated calculators like the RuleBlade Subnet Tool.
I want to leave you with this final thought-provoking question. CIDR was a brilliant, necessary fix that completely reshaped how we route traffic globally. But with billions of new devices coming online every single year, and CIDR actively preventing the rapid exhaustion of IPv4, how much longer can these 32 bits truly sustain the exponentially growing internet? It's a fascinating challenge, and honestly one that paves the exact path toward our eventual, fully IPv6 future. Thanks so much for exploring this explainer with me today, and keep learning.
Thanks for watching.